Uh, are we live? Hello, Jordan. Are we live? Can I go
Yes,
on?
Shiv, we are, yes.
Excellent, excellent. Um, Good morning, good afternoon, good evening, depending on where you are. And Eid Mubarak to all of my friends of the faith. May you always be blessed with His mercy. And welcome to Ericsson's showcase session. For those of you who don't know me, I'm Shiv Bakshi, and I'm a VP in the Industrial Relations in the office of the CTO at Ericsson. When I'm not hosting showcase sessions, I'm engaged in spectrum technology and policy matters in Africa and Middle East. I'm also the CTO's point person for WRC matters and for WTDC development matters for the region. I'm joined today in this session by three distinguished colleagues who will do actually most of the heavy lifting. First amongst them, the distinguished Zoran Lazarovich, our CTO for Middle East and Africa. He will be followed by my friend Kenneth Walstead, our senior expert in the CTO's office. For those of you who don't understand the senior expert designation, it's like being a professor emeritus in academia. And then, of course, my good friend Shiletsi Makofane, whom many of you know, our head of government relations in Africa. So let me put the topics: dedicated network for Industry 4.0 and the role of 5G and licensed spectrum for local industries in context. Most often, when we talk of 5G, we almost invariably tend to talk of the technology in terms of its impact on individuals, like what cool things the consumers can do with this particular generation, new generation of technology, right? But if you look at the history of technology, you will notice that apart from a very few early adopters, a new technology is almost invariably first adopted by the industry, and for somewhat obvious reasons. The industry wants to exploit the efficiencies and productivity gains that the particular technology in question promises. 5G is no different. 5G is not merely a new generation of mobile technology with still higher peak data rates and greater throughput. Of course, it does that. But it is also a network platform that, with its software defined logical network slices, builds, which are built on a shared infrastructure, actually, promises huge efficiencies to the industry, all kinds of industry, from manufacturing to shipping to mining to health to education, everything. 5G is designed, if you permit me to say this, to help us realize the promise of Industry 4.0, which, as many of you know, is driven by digitization and hyper communication and information processing. 4.0 is disrupting old value chains and creating new ones. The transition to Industry 4.0 will, of course, depend on interconnected smart operations both locally and globally. The strong interconnectedness is key for adaptability with the capability to connect products, people, and processes. This transition to Industry 4.0 creates huge opportunities for growth and economic development. So, if Africa seeks to exploit this tremendous opportunity to become a significant player in the global production, distribution, consumption chain, it must lay the groundwork for high end connectivity that 5G promises. If a region is not part of this global production, distribution, consumption chain, it will not be able to appropriate the economic value that flows or comes forth from reconstituted value chains that we have seen up to date. To attract global capital, also, regions and countries must compete for investments, as you know. One of the more decisive elements of attracting global industry and investment is to provide the communication infrastructure for your country, along with, of course, an educated workforce, security, regulatory certainty, and all that good stuff. In this particular showcase session, we will discuss Industry 4.0 scenarios so that African policymakers can be more aware of connectivity infrastructure that is taking shape elsewhere and what Africa may also be able to offer global capital if it wishes to attract investments to its shores. This will, of course, spur economic activity, which will have secondary and tertiary impacts, including a peace dividend. Zoran will speak to the dedicated networks for the dedicated networks that are necessary for Industry 4.0 uses and the foundational role of wireless connectivity in enabling new cases. He will be followed by my friend Kenneth, who will speak to the importance of 5G and licensed spectrum for local industries. Shiretsi and I will bring up the rear by stimulating a discussion and fielding your questions. And with that, Zoran, the floor is yours, my friend. Zoran?
Thank you, Shiv. Thank you, Shiv. Good morning, good afternoon, and Eid Mubarak to all Muslim friends. So let's start. We're going to look at, as Shiv was saying, at importance of 5G dedicated networks or private networks for Industry 4.0. So if you start with business potential, Ericsson, together with Arthur DeLito, prepared report looking at 10 industries, which we can see here on the right start, starting with manufacturing, energy utility, healthcare, and so on, where it was estimated that industrialization revenue will be $3.8 trillion by 2030. Big part of this industrialization revenue will be enabled by 5G. $1.5 trillion is expected to be enabled by 5G. Other 3GPP connections or some of non-3GPP connections estimated to cover remaining of the revenue. And then from this $1.5 trillion, it's expected that service providers can address around $700 billion. This is a big potential, and I think how important it is even better can be illustrated on the next picture, on the next slide, where we see growth expected for ICT players in industry digitalization. So the growth is estimated at 12%. So CAGR is from 2020 to 2030 expected to be 12%. For comparison, revenue growth for operators current and something which is estimated to continue if the same business is addressed is only 0.75%. Majority of this growth is expected to be in the first couple of years, first 5 to 7 years, where the CAGR is estimated to be up to 50%. And then the growth will a little bit slow down coming to 2030. If you look from different perspective, if you look at the number of wireless connections, there is a report from ABI Research which is showing that number of wireless factory connections by 2030 will grow 100 times. You see this on the graph, this blue lines, an exponential growth of wireless connectivity in the factories compared to fixed connectivity. Sometimes between 2022 2023, it's expected that it will overtake number of fixed connections, and then it will exponentially grow toward 4.7 billion connections estimated by 2030. So why are we going to have this number of wireless connections? Well, they are fundamental really to enable new use cases related to Industry 4.0. And we are looking at this use cases which will be enabled with 5G. We can look at these three groups of use cases, which we are seeing at the moment. We see digitalization. We are referring here to connecting all these sensors which will be there in machinery, in the pipes, everywhere in the industry, collecting massive amount of data from operation, and then based on this information, building the model, building digital twins on which we can test how to improve operation, apply AI analytics, and then improve this in real life operation. The second area is automation and remote control. We're going to look some of examples of remote control of machinery, but this is very big use cases which we are seeing now. It's deployed. It will improve productivity, but also improve the safety. In many cases, it's hazardous conditions in which this machine is working, and it's really beneficial if this can be done remotely and not really having person on the place to run those machines. And at the end, connected workers. And when we say on the connected workers, we're not talking about only voice operational connectivity. We are referring here big time to AR, VR connectivity, to XR connectivities. what we're seeing is a big use cases in number of industry already deployed is that staff is using augmented reality devices to perform complex operations, maintenance activities on the field by using AR, which can guide towards solution, which can recognize the issue. Maybe some of the experts will be sitting in the central office and then suggest what is solution, or again, AI is used to guide what should be deployment. For all of this, we need 5G. We need 5G for connected workers because this is massive communication, and 5G can provide this high throughputs. Or when we was talking automation, we need low latency, and again, 5G can enable low latencies. How this connectivity is enabled today? This is done predominantly with dedicated networks, with private networks. And we really see momentum now in deploying private networks. You see some of the announcements on the right side in various industries, automotive industry, airports, ports, manufacturing, oil and gas, utilities, in a number of industries where the same concept fundamental is used. Deploying dedicated networks, 5G dedicated, to enable this 5G connectivity, providing this low latency, high uplink, downlink throughput, on which we are deploying now use cases. To visualize these use cases, we're going to look a little bit more at industries like ports and mining, which are very relevant for Sub-Saharan Africa. So let's take a look at the ports and see some of the use cases to which we are referring to. So this is a port. This is how some typical ports look like. And what you have in the port, you have this big cranes called ship-to-shore crane, which used to load containers on the ships. Then you have cranes in the yard, rubber tire gantry, RTG cranes, which looks to rearrange the containers in their yard and to load these containers on automated gated vehicles, which transport containers from the backyard to the STC cranes to load on the ship. Big use case in the ports is to enable remote control of these cranes. How the cranes are controlled today? They're controlled manually, meaning that person is sitting on the cranes and control the crane. Or in some cases, they are controlled remotely, but with a fiber. We have some kind of, maybe here it's visible, some kind of special fiber through which control is done. But of course, because this is a moving equipment, there is a limited movability when you connect something with the fiber. This is a super expensive piece of equipment, multi-million piece of equipment. And it's also important to say how it's important reliability in functioning of this equipment, because 1 hour of loading the ship, 1 hour of usage of these cranes is in the range of $100,000. So if we can enable reliable connections, which are going to be wireless, which are going to enable higher movability of these cranes, then we can optimize operations. We can reduce number of cranes, which are going to be used the place, which is going to be, of course, massive cost saving for the ports. And on top of this, of course, by remote, it's going to be much more efficient and more safe instead of having persons on the crane. We was doing a proof of concept for this deployment, and I want now to visualize this, and I will run the video to show you how these cranes can be controlled remotely with 5G connections. So let's take a look at the video. Sorry for this. Let's try once more. Okay. So this is those STS, ship-to-shore cranes. And you see this, I was referring to this fibers on the wheels. So currently, if they are controlled remotely, they are controlled through this special reinforced fiber. What we was doing, we was deploying this trial with our partners, Chennai Unicom. And you will see our equipment. This was test equipment which we deployed on the crane. The use case is to connect all these cameras and programmable controllers back to control center, where staff now can remotely control the cranes, load, offload containers to the ship and from the ship. It was successful proof of concept, and this is big use cases. Many industry. You see our partner here, ZPMC, big producer of these cranes for ports. So many really companies are working on enabling this use case. What was the requirements and how 5G and why we need 5G to fulfill this kind of requirements? So here is you see that also. You saw that also during the video. What is solution for the use case? So we have this. In this case, 30 plus HD definition cameras, which takes the video in real time in many angles from the cranes of the container, so that this video is sent back to the control center so that staff can control. And this is first the big requirements because when you watch HD video on your mobile, it's only 3 megabits per second or something, because we can compress the video before sending. But here, because of the latency, it's not possible to do compression. It's going to introduce unacceptable delay. So we need to send the raw data, and raw video image is much higher. We are talking about 20 megabits per second. And then 30 times plus, then we have very high uplink throughput requirements, particularly complex because it's uplink requirements. However, 5G can address this. Then we need also low latency, because we need to control these PLC, programmable controllers, through which we are controlling in real time crane operation. Again, we need a low latency here, because at the moment when somebody from control center move that joystick, we want in milliseconds to have reaction on the crane. Otherwise, of course, it will not be possible to control the machinery remotely. And finally, we need guarantee reliability and quality of service. If we look at the solution, and I want to highlight here what is the main component solution, because this is the same solution actually which we're deploying across the industries. So what is the main components of 5G dedicated network? Here on the left side, we see that what we was mentioning, components which are sitting there on the crane, cameras, PLCs, and device, 5G device, which is connected to the network. But if you look at the network side, first, we need to provide, obviously, coverage for the industry area. And then, what kind of coverage? Is it outdoor or indoor, macro site or indoor site? What kind of spectrum is required? Very much depends on the use case. Here, we was referring to high uplink throughput, which is required for this particular use case. And in this solution, millimeter wave may be the best spectrum to use, because it can provide this high capacity throughput. In some other use cases, some other deployments, low frequency spectrum may be good solution, because maybe we need to have good coverage, maybe we need to have penetration, like for the mines, or going some indoor coverage. So it is really not one solution fits all when it comes to the spectrum. It's very important that whoever is deploying solution, whoever is deploying dedicated networks, has the option of the spectrums which can be used. In some cases, actually, the best solution is to use a couple of spectrums to deploy the most optimal coverage. That's the key component, of course, and my colleague Kenneth will cover more on the spectrum for dedicated networks. Second key component is core network, or some of the functions of the core network which are deployed on site. The most important is to enable that user data will stay locally. We have the user plane breakout, so that we first enable low latency. If we are sending the user data all the way to the central site and back, then we definitely cannot fulfill latency below 10 or 20 milliseconds required for some of these use cases. And second reason is security, obviously, to keep all the user data locally there in the factory. 5G networks, 5G dedicated networks are deployed on the cloud infrastructure, on the same cloud infrastructure, on same servers on which this industry may deploy some applications, some local IT applications which are used, for instance, as this for controlling this, monitoring the cranes or any other application we need. We are representing also here that some of the function can be kept in the central cloud, for the operator's central location, like control plane functions, operation maintenance function, but that also depends on the solution. Some of the industries actually insist that all of the functions are deployed locally, so that's to the level independent if something happened to this link between the locally deployed functions and central functions. So we are talking about two use cases, or one use case of controlling remotely this big ship-to-shore cranes or controlling RTG cranes. But the same network actually can be used and should be used to enable other use cases. And here is very popular automated guided vehicles, control automation, then video surveillance. Is it video surveillance with a fixed camera or video surveillance with drones, which is again very popular across different industries, using the drones to inspect something which is on the height, like inspecting these cranes or inspecting the towers. Then, of course, the same network will be used for communication system. And then finally, very much valid use case for ports, but many other industries also is real-time asset localization, having the sensors and then locating the asset across the port. To visualize business potential, internal investment, we build this kind of calculators for a number of industries. And here we are looking at a value calculator for smart ports. And what we are considering 5 use cases, which we mentioned also here: automation of RTG cranes, remote control of ship-to-shore cranes, cellular connectivity for AGVs, automatic guided vehicles, condition monitoring of equipment, and then drones for surveillance and deliveries. And for defined size of the port, and in this case, you see what we are defining, a return on investment is only after 2 years. After 5 years, the return on investment is reaching the level of 178%. So same network will enable a number of use cases. Very good report, a white paper which we wrote with our colleagues, partners in industry, highlighting all these use cases and potential for the port in bringing these use cases. When we're talking about dedicated networks, so the same concept is actually applicable across the industries. So what we envision is it's going to be hundreds of thousands of dedicated networks in the country, covering same concept, enabling different or similar use cases across the industry. Across, is it public safety, is it transport, is shipping, mining, many different industries. We're going to present shortly one more example, which we think it's relevant. Again, relevant industry is in mining. And here we have a project which we did with in Sweden with Boliden, which is a mining company in Sweden, in their largest copper open pit mine. And again, the use case is to control the machinery remotely. By controlling this heavy machinery remotely, we can increase productivity, but also, of course, increase the safety. And the second use case, very important here, is predictive maintenance, using sensor for asset condition monitoring, which allows Boliden to proactively perform maintenance on machinery to reduce accidents and downtime, so increase productivity again. Smart mining market is projected to triple by 2025. Here you see from Murder Intelligence information that 25% of mines are expected to adopt autonomous operation by 2025. We also have a smart calculator for value calculator for mining, for both surface mining and underground mining. And here we can see example for underground mining and which use cases which was considered. We're considering again 5 use cases: autonomous vehicles, real-time condition monitoring, remote control of drill rigs, drone inspection, and smart ventilation control. And in this case, the return on investment is estimated in 3 years, while after 10 years, it's 256% return of investment. If you look at the use cases, smart ventilation control is majority of the return investment, and that's not surprise. If you look at this very good report detailing these use cases, we can see that 50% of energy consumption in underground mines is actually related with ventilation control. 15% of total energy cost in underground mine is related to ventilation control. So introducing smart ventilation control capabilities as well as remote machinery, so that we don't need people going underground, or reduce number of people in those particularly sertitious conditions, can have both safety improvements but also productivity and cost saving improvements. And here, finally, I want to close with one more video, one more example of the use cases. This is example which is used in our recently built factory in China. It's about warehousing, inventory counting, but again, I think it's very much universal for many industries. Where we have warehousing, we can deploy this use case. So this also shows that same concept for dedicated networks, and many actually of use cases are very similar, if not the same. So let's watch together this last example.
As one of the cutting-edge techs, drone tech is introduced to factory to approach Industry 4.0. In the past, the inventory counting required the worker to drive forklift to fetch goods and scan the code to compare with Enterprise Resources Planning, ERP system. It was both time-consuming and inefficient. Now the drone carries out autonomous flight to complete the code scanning task by using internal map and radar navigation. And the scanning of all the physical goods info from multi-racks can be done under a single flight. Equipped with 2 cameras, the drone can check goods safety and scan the information at the same time. By 5G private network, it transmits real-time video data back. 5G drone greatly reduces inventory counting time. It makes a remarkable improvement in terms of efficiency, being increased by 50 times for inspection precision and shrink the damage risk caused by multiple physical movement. The drone automatic reading function also benefits to realize precise positioning of specific goods and facilitate goods selection. In addition, it is quite flexible for drone engineers to set new flight routes via updating 3D map and system when warehouse layout is readjusted. In the future, enabled by 5G network, drone can complete autonomous docking and wireless battery charging. Enabled by 5G cloud technology, drone will achieve full automatically inventory cycle counting job.
Very good. This ends my presentation. Shiv, back to you.
Thank you, Zoran. This is cool. Every time I listen to you, I learn something new and something insightful. So thank you for sharing your insights and telling us about the use cases that are applicable across industries. I will now move to invite my friend Kenneth Wallstead, our senior expert, to talk about the role of 5G and spectrum in dedicated networks, or Industry 4.0. Kenneth, the floor.
Very good. Thank you, Shiv. Thank you, Zoran, for the introductions, and good afternoon, ladies and gentlemen. It's a pleasure to be here. I know time is short, so I try to be focused on the presentation. We can move on to the next slide. Here is a bit why do we talk about 5G, and why do we talk about licensed spectrum, and why do we want to combine them? And I summarized that in just a few rather basic statements. Licensed spectrum first, that brings interference control. And you need to have interference control to be able to deliver a service, a predictable service. We also know that 5G provides mobility local and wide area, as with earlier cellular generations. And it also provides this ultra-reliable low latency communication, where you can actually get down to predictable latency to milliseconds. It's one thing to have a latency on 1 millisecond, but to have that always, that's the important thing for industries. Because the requirements for a production industry, if you take robot arms, they are quite extreme. They are built for wired connections where there is no packet losses or no unknown delay glitches, I would say. So license spectrum and 5G is needed if you want to go wireless in industry. Of course, and that's a fundament, but you also need the network, of course, deployed, a high quality access network. And Soran just made, I think, a very good description of such a network that could be provided by Ericsson or other vendors. Next slide, please. What is then an industry? This is just an example of a production industry. Of course, there are many different kinds of industries. But taking in production, then you have a lot of different tasks needing different types of connectivity. You have a lot of simple sensors that can be served by narrowband IoT or Cat-M, more or less an LTE standard, but also adapted in 5G. You have these robot arms that needs this ultra-reliable connectivity with 5G. You have still voice services. You need to access internet. You have video surveillance, needed fast, speed, best effort connectivity. Enhanced mobile broadband, that could be over LTE or 5G. And then you have produced goods going out of the factory, and you have inventory and stuff coming in, the supply into the factory. And you also have workers coming in and out. So you need absolutely a wide area connectivity for the goods and the factory workers. Next slide. So then we saw that it's not that you only need one technology or one access. You need several access technologies in a production facility. These access technologies there are available on different frequency bands. Different frequency bands also have different characteristics, as you all know. If you go from the top, if you take the millimeter wave bands, you can provide extremely high capacity, but with limited coverage. And also the millimeter wave bands, there we only have 5G. We can't provide all the technologies like LTE. On the mid band, we call them sub 6 GHz band, there are TDD bands. They provide rather good coverage actually, and also very high capacity, not as high as in the millimeter wave band. Then you start to interfere with the external networks. You need the TDD coexistence with external networks. On the mid band, they have both LTE and NR. And then you have the low bands, which provide, of course, very good coverage. Also, some of the access technologies are only deployed on low bands, for instance, narrowband IoT. So if you have a local factory, you need more or less to play on all different frequency bands if you are to serve all the different needs of this production facility. You need the high bands, you need the millimeter wave bands, as well as the lower FDD bands for narrowband IoT. And it is the combination of the frequency bands which is enabled by both 4G and 5G, which is a bit of the strength of the mobile technology here, that you can serve a factory with all their use cases on different frequency bands and also on different technologies or access parts, including devices. Next slide, please. So if you happen to have a local industry, it could be a harbor, as Soran's example, or production, or an airport, or something that is rather local in nature. You of course, you want a licensed spectrum and you want a 5G system. How can you then get licensed spectrum? Well, there are, in principle, 3 different main routes to the spectrum. First, you can sign a service level agreement with one operator or several operators owning licensed spectrum. Then the operator can provide also the equipment and the services to your industry. Or you can do it your own on the spectrum for the operator. But in the first case, it's the operator who provides the network for your industry. Then, since the operator owns all different spectrum bands, you have the capability to serve all the use cases, including narrowband IoT or ultra-reliable services. Then it's, of course, a challenge to get an agreement between the operators and the industry. You need to sign and have an operational agreement, because if you get glitches in the service, that will impact your ability as an industry to deliver your products or serve the hardware or whatever you're doing. The second option is you can lease spectrum locally from an operator. This has not really got traction globally, but in some countries there is now mandatory leasing proposed. So if an operator is not using the spectrum, it has to lease it out to reasonable terms to a local industry. And third, you may set aside spectrum for local licenses. That has happened or is happening in several countries. You have the CBRS spectrum in US and in Germany, Sweden, and some of the European countries. You have mid-band allocations and also some allocation of millimeter wave bands. We have learned if this is going to be successful, you need to design this allocation for the needs of the industry. And an industry is rather local or very local. So one good way, which the Germans have done, is to connect the spectrum ownership with the real estate ownership. Also, you need to be careful so you use spectrum that is used globally. Otherwise, you will not have an ecosystem of devices for that deployment. We have learned that the interference protection between this local industry and the wide area spectrum is quite cumbersome, but doable. You need protection zones and limits of interference in both ways. You should also have means to avoid spectrum hoarding, so you are not buying spectrum on speculation. That it could be that you connect spectrum ownership with the real estate ownership. What we have seen in Europe and US is one mid-band range, let's say 80 megahertz on mid-band, and in some countries some millimeter wave bands have been allocated for local use, which could be useful, but it does not cover all the use cases. Like narrowband IoT is not working on mid-band or millimeter wave band, so it will not provide a complete solution if you go the third route. The first route, sign a service level agreement, on the other hand, and an MNO does provide, if you're successful, a complete system. Next slide, please. So a bit of a summary. First, of course, 5G on licensed spectrum is important for development of nations in industries. We are very aware of this. We have also learned that multiple licensed spectrum ranges will be needed for industries. It's not enough with one spectrum range. There are three options for industries to obtain spectrum. Either you can have an SLA with an MNO using MNO spectrum. You can have a local licensed spectrum set aside by the regulator. Then it should be very, very local, and it has to be licensed in a manner that is fruitful for the local industry. And there are some trials on mandatory leasing in a few countries. And finally, recommendations. Licensing of frequency bands. Of course, we need, as Shim mentioned, is the lifeblood of the society, spectrum, and of course of 5G. So we need more spectrum bands for 5G. It's also important that existing frequency bands that is technology neutral, so you can allow 5G in all current frequency bands as soon as feasible. When you get 5G on lower bands, you can have a standalone core, for instance, an SA deployment. It is also important to have corporations here that operators do support industries with 5G. You need to sign these SLAs. The operator has a very, very good opportunity here to help the industry. And finally, as we all know, ensure efficient usage of all spectrum resources. All spectrum should be used efficiently. It should not be put in vain. You need to combine spectrum resources for have a complete service offering and serve all the needs for the industries. Thank you. That was my final slide.
Thank you, Kenneth. There is a reason why I've always thought of you as my technology guru. Thank you for your insights and for your thoughtful presentation. So, Shiletse, one quick question for you. What do you see as the key value for African continent for the presentations that Zoran and Kenneth are making?
Thank you very much, Shiv, and thank you, colleagues. I think there's very good use cases that has been highlighted by Zoran, and I think there's been a lot of talks about what is this 5G, what is it going to bring, why do we need it? And I think there's use cases that we've seen. It's basically going to be able to propel the countries that are first movers to be able to be competitive. I mean, today we are talking about the Africa free trade. So therefore, it means it becomes very important to use the technology to extract your minerals, to be able to more efficiently, to be able to process, and then also be able to deliver your minerals around the world. So I think that's a very good from the use cases perspective. And I know we don't have much time. I had a lot of comments on Zoran, but I think I'll quickly also on the port. I think very critical. Obviously, every port is a very lifeline for every country. And I think that's very highlighted in terms of how we can efficiently. And most of the ports needs a lot of that automation. So lastly, I think on the Kent's one, I think it's a very critical one in terms of showing on how now the industries are automating, and something of interest for me as well, obviously, that I can be able to comment about as well in terms of the recommendations, is that in the continent, obviously, there are some of the spectrum that are already allocated, which has been used, different licensing, different number of players in the market. I think the key thing that maybe I might want you to reflect on, if you have met an example or something where around the world where the options you have talked about are being mixed. So which means there could be a industry that might be able to get the millimeter wave because maybe those ones are not yet out in the market, and then but also be able to can partner with the operators or an MNO in terms of using the other mid band and the lower band. So I think that would be something of interest for the continent, because some of the mid-band, lower band are sitting in the different hands. And it will be good for our policy makers maybe to understand some of those options. So, thank you, Shiv. Back to you.
Thank you, Shiv. So are you thinking of trial licenses for industry in millimeter wave? Is that what you're thinking?
Yes, I think what I'm trying to think is that if we then do that trials, if then the country has already allocated your mid-band and the lower band, how does the industry maximize the use of those three bands if they own in particular one, and then be able to can work with that? So that's why I wanted to check if maybe Ken wants to comment on that, because the continent has got a little bit of that picture. Yeah.
Yes, I can comment, and I think it's a very, very, very good question, and it is actually happening. If you take Germany, where they are now allocated 3.7 to 3.8 for local deployments, it's 100 megahertz on the mid-band. The major operators are combining and offering their assets together with the local deployments of the industries. So it's in the hands of Deutsche Telekom, for instance. They are helping the industries with using their own spectrum and combine with Deutsche Telekom spectrum. And I think it's likely we'll see this kind of hybrid models flourishing in countries where local dedicated licenses are deployed. I think also industries realize that they don't really have the competence to run a mobile network, nor do they have enough spectrum actually to serve all the needs of the industry. So they are very good in the hands of also serving by the operators.
As always, there are so many thoughts to be discussed and so little time. There was a question that was raised on YouTube, people who were watching, which, in your opinion, is the most appropriate approach, given the approaches, particularly in Europe, for providing access to spectrum for verticals? You have 15 seconds. Kenneth.
For me?
Yeah.
Yes. Yeah, I think number one here in the examples.
Okay.
I think if you could get an SLA with the operator and the operators actually are cooperative in the industries, then you can get all the needs of the industry served by the operator. We know
Zoran,
this
you
is
agree?
Absolutely. I think it was mentioned, I mean, we're going to have different requirements for different use cases. So one spectrum will not fit all the use cases. So it's very important to have access to all the spectrum options. And that can be done only if we are cooperating with operators.
Thank you. With that, I think I'm obliged to conclude this session. So thank you very much, Zoran. Thank you very much, Kenneth. Thank you very much, Shiletsy. I wish we had more time, but apparently we don't. I'm looking at the clock ticking away, and we are already beyond our allocated 45 minutes. So thank you very much, and thank you to the audience for listening in. This is available for replay at a later point, should you want. And if you have questions, please reach out to us. Jordan at Forum Global should be able to help you if you don't have the contact information. Thank you very much and have a good day. Bye, guys.
bye-bye.
Thank you.
Thank you all.
Very much. Bye.